Hello great tools, welcome to my channel, and I hope you are resting well. Please don't relax, study. This was by request by one of you guys. So this is the paper that was written for the trials in 2022 in the EC. So I hope these papers will help you to gather your thoughts and to prepare yourself adequately for your upcoming trial examinations. Please do have a look at the videos I have done in the channel for all sections in paper 2 and even the full papers to gain some sort of a clear idea of what is expected of you and exactly what are your strong areas or your strong points in scoring maximum marks. Otherwise, let's just have a look and see what is in here. Operational instructions are very important to make sure you are clear. The rounding off business here to 2 decimal places, no more, no less, all right? And then just be aware that diagrams are not drawn to scale, so don't try to read directly. Otherwise, we've got formulae in case one needs to rescue themselves. So let's look at question 1. This is a question from grade 11 already. So we are dealing with grouped data. All right. So we are told here 100 athletes took part in a long jump competition. I made it to regionals back in 2000, from primary schools, of course. The distance in centimeters, right, of their best jumps is summarized in the table below. So we've got all those classes and their corresponding frequencies. Now I told you complete the cumulative frequency column in your answer book. So let's look. Okay, there we've got it. So all we do is just take this one across. We get a 6 and then we add the next one. 6 plus 14 gives us 20. Right. And then 20 plus 16 gives us 36. 36 plus 42 gives us 78. 78 plus 14 gives us 92. 92 plus 2 gives us 94. 94 plus 3 gives us 97. 97 plus 2 gives us 99. And the last class gives us 100. So whenever the last class corresponds with the total number of our athletes, then it means we have done this correctly. So we take our 2 marks and we move. Next question says draw an ogive, or the so-called cumulative frequency graph, to represent the above information in your answer book. So let's look for it. Okay, there we've got it. Now the question is, what do we do here? Well, we see that we've got to find what is the smallest scale on the horizontal axis. What is that tick there? So first we need to find that big distance of the big block. So it's 400 minus 350, that gives us a 50. Then we've got 1, 2, 3, 4, 5 small blocks. They would divide that by 5. That gives us a 10. Okay? And then we've got to look across the vertical axis. What is that? So basically from 0 to 10, we've got 1, 2, 3, 4, 5. So that divided by 5 gives us a 2. Okay, so the smallest tick is a 2. So we want to go and do our ogive quickly. So when we do our ogive, we basically take the upper limits of each class. All right. And then, of course, the very first plot is going to be the lower limit of the first class, because that would coincide with the upper limit of the previous class, for which the cumulative frequency is a 0. So we want to plot 420 here is over here. Okay. The next one is going to be 460. It goes with the 6, so this is 2, 4, 6. And then we've got 500, which went with 20. Okay. And then we've got 540 that went with 36. So 246. Okay. And then we've got 580 that went with 78. So 550, 60, 70, 80, it went with 78. So this is 2468. Okay. Great. You can see here that's the biggest jump, right? Because there were more frequencies initially there. Okay. So we've got 620. 620 went with 92. So 620 here. 590, 92 is over here. Okay. And then we need to find 660. It went with 94. 660 went with 94, so that's going to be here. Okay, so 94 over there, 660. Then 700 went with 97. 700 went with 97, so this is 94. 96, 97 is going to be in between. Oh, don't do it. Okay, sometimes it's not going to be exactly accurate. And then 740 went with 99. So 740, 99 also in between there. And then 780, 50, 60, 70, sorry, 60, 70, 80 is with 100. Okay, so let's draw our ogive. There it is. So we've got our ogive completed. So we take our 4 marks and we smile. Okay. Next question. 1.3 says, use the graph to estimate the median jump. Okay. So we always know that we take it from the top. So we've got 100 athletes. So half of them are going to fall on 50. So we just take it to the graph. Okay. And then we read it down. Man, stop touching. Damn it. Okay, so if we see that, we can see that this is between 550 and 560. So that's essentially 555. So we can just say here, the median, oops. The median jump is equal to, we can say 555 centimeters. Of course, you will be given a range here so that you get it right, because it's all about how accurate the graph is. Okay, now it tells us what percentage of athletes jumped over 560. So we just have to look for 560. 560 is over here. We take it to the ogive as well. So we've got to intersect the thing, right? Fully. So when we intersect our graph, it takes us like it takes us there, okay? Because that is the intersection nicely. All right, so what do we read there? That was 50, 52, 54. So that's 54, ne? Okay, so we see a 54 there. Great. let's see, 2, 4, 6, 8, yeah, that's 54. Sometimes it's a bit silly, but now we had 100 athletes, so the number is going to be those guys, okay? That is those guys, that is that difference. So to do 1.4, we know here what we need to do. We're going to say the percentage of athletes is going to be the 100 minus the 54 that we see here, all over the total, which was 100, multiplied by 100%. So these two guys will do it, and then all we're left with is 100 minus 54. That's 46, okay? So we're getting a 46%, okay? Again, this is an answer that is going to depend on the accuracy of the business that we are doing here, okay? So sometimes it's not the easiest to really do this right. So as long as you show on your ogive, that should be enough. Because in my opinion, there shouldn't even be a specific answer for such a question. But purely you follow what is drawn by the student, as long as it is acceptable. So we're getting 2 marks here as well. So basically maybe for that expression and the answer. Not a problem. So we take our 10 marks with a wide smile on our face. We move on to question 2. Maybe let's squash it here. Okay, so question 2, this is now grade 12 material, because here we do what we call bivariate data, okay? There's 2 variables, x and y, all right? So we told you the following table shows a comparison of distances in centimeters as well. Jumped, we're still doing the long jump, by 6 long jumpers, and the hours spent practicing their jumps in a week. All right, great. So now it says determine the equation of the least squares regression line. Okay, easy stuff. So we need to input our data onto our calculator. So we answer like this, 2.1. So obviously we input our data, and then we go for shift, then we press button number 1, and then we press option 5, which is regression. We press A and equal sign. A becomes 3, 3, 6. Now we have to round off to 2 decimal places. This is going to be 70. And then we need the value for B. Again, we repeat the procedure, shift 1, 5, and then we press option 2. It gives us 56,99. We can say therefore our equation is going to be 336,70 plus 56,99x. Okay, so that's easy. So you get a mark for those and then for the answer, okay? 2.2, we are told you predict the distance jumped by a long jumper who practiced 5.4 hours. So we know that from our equation, we just substitute 336,70 plus 56,99. For x, we put a 5,4. Easy. We just punch it. 336,70 plus 56,99 into 5,4. All right, so that gives us a 644, comma 45 to 2 decimal places. But now this is centimeters because that is a jump. Okay. All right. Okay. So for the substitution and for the answer, that's how we score the marks here. So 2.3 says comment on the validity of the answer in question 2.2 and motivate the answer. Well, we can say here the answer is accurate, or you can say it's valid. All right, since the time 5,4 hours is within the domain of the hours. The writing is horrible. The domain of the hours in the data set. Okay, great. So if you look here, you will see that the smallest is 2 hours and the largest is 8 hours, and 5,4 falls within that domain. So essentially this is the so-called, if you think about it, you can write in brackets that this is an interpolation. So you want to display that you really have the knowledge of this topic. All right, great. So here you will be given a mark for saying it is accurate and for your reasoning, okay, as comprehensive as it is. So we've got 2.4, which we are given 2.4.1. It says now at the end of the event it is found that the measuring tape used was broken and all the distances decreased by 13 centimeters. Not a problem. How will this influence the mean jump? Great. Remember, the mean is going to be all of those little data sets, right, over their total number, right? I don't know what to say here, but it's crazy what I did. Okay, it's the sum. But now look, if we decrease this by 13, it means the numerator decreases. So once the numerator decreases, what happens to this? That one also decreases, is it not? So it will decrease. All right, so we've got 2.4.2. Well, what about the range of the jumps? Well, we know that the range R is going to be the maximum minus the minimum. The maximum here was what? We can see that 780 is the biggest, whereas 420 is the smallest. So this is essentially 780 minus 420. That gives us 360, né? Yes, 360. Now that's fine, that is centimeters. All right, that was our range. Now what happens? Remember, now our new range is going to be 780 minus 13, né? Minus into 420 minus 13. So that should not change, is it? So let's say 780 minus 13 minus 420. Oops, let's just sort it out. 420 minus 13. The range doesn't change because, I mean, it should not. so it does not change. So we will say it will not change, or you can say remains the same. Okay, so what about the standard deviation? Again, the standard deviation, because these data points are decreasing by 13, the standard deviation should also be the same. Okay, great. So that is the story right there. So we're getting a mark for each one. Hopefully they are correct. So we take another 10 marks in the bag. So we've got 20 marks in our lovely bag. Okay, let's move, guys. It's easy stuff here. Now let's do some serious paper 2 mathematics. Question 3. Now here we're going to have to analyze. We can't just go, okay? So question 3 says, in the diagram below, by the way, when answering these things, use the doctor's approach. I explained this one in a video for one of the grade 11 papers I did, okay? So if you don't know what that is, please go look for that video. It's a full paper from grade 11, paper 2. You will see there what is the doctor's approach. Anyway, in the diagram below, E, which is the point P and 8, we can see there that there's our E. P and 8, again, this is a potential question. Right, F, which is the point -2 is to -3. Okay, we can see there's our F. And then G, which we don't have anything. H. So we can see H there. We can see it. It's the point 8 is to 7. Our vertices of a rhombus are E, F, G, H. So what do we know about a rhombus? So you need to analyze words. So we know that the rhombus, the opposite sides are equal in length and they are parallel to each other, okay? Okay, that's what we know about a rhombus. What else do we know about the rhombus? We know that the diagonals of a rhombus bisect each other at a common point, okay? All right, so meaning EM is equal to MG as well as HM is equal to MF, all right? The other property is that the diagonals of a rhombus meet each other at right angles. Okay, so we can just show 1 over I1. What is that? What is that? Superb. Okay. Anyway, so we just wanted to show this. You can show all of them, but that's just the story. Okay, now that we've sorted things out, let's read on. Now we're told the diagonals EG and HF intersect at M. So M is the common point, okay? So that's the midpoint. And cut the x-axis at K and R respectively so we can see those points. Fine, what can we do? Since we've got 2 points on F and H, we can actually determine the coordinates of M. Okay, easily. And then, because it is an average between those 2 points, we can use those 2 points to find the gradient of that line as well as its equation. Okay, and then since the gradient of that line is some sort of a perpendicular gradient to the line EMG, we can use that property to kind of work out the value of P. Okay, that's cool. And once we know the value of P, we can use M and E to find the coordinates of G. Once we've got coordinates of G, we can easily work out the gradient of that line and its equation, the gradient of that line and its equation, and. Okay, so now that we know what to do, we just want to start solving. Again, read through these questions before you answer. Okay, don't start answering. Skim and scan so that you can figure out what you need to do. Now we need the coordinates of M. We already mapped out how we're going to go about this. Okay, we want the coordinates of M, so we know that M is the midpoint of FH. Okay, what is that? We know that these are the diagonals of a rhombus bisect each other. At M. Okay, so I'm just giving a comprehensive approach, which is not really a big deal. This implies that M is the point. So we can say x at F plus x at H over 2 is 2x, not x, man, stop doing that, y at F plus y at H over 2. It still implies that our M is this story right there. This is minus 2 plus 8 over 2. Okay, you can still jump in and not write the formula actually. This is minus 3 plus 7 over 2. You can say therefore our M is, this is now 6 divided by 2, that is a 3. That is now 4 divided by 2, that is a 2. Is that valid? It is valid because it's a point in the second quadrant. So we can write these coordinates in. So we've got 3:2. Not a problem. Now, we were only getting 2 marks here for the substitutions and the answer, okay? But everything is important. Do not be haphazard. Bad habits do not reward you at all. So don't even learn them at all. Okay, gradient of FH, again, is very easy. M FH is going to be y at H minus y at F all over x at H minus x at F. Nah. Yeah, so y at H is a 7 minus into minus 3. This is going to be an 8 minus into minus 2. So that's 10 over 10, which is 1. So that's good because it's a positive gradient. It may just be a matter of the value, but we can accept its sign. Again, you get a mark for that substitution and for the answer. Okay, easy stuff, but show everything, please. The instructions said every calculation must have a formula, a substitution, and whatever else you've got. Okay, a diagram, etc. Now it says let's find the size of MKR. As we can see here, this is the angle of our interest. MKR. So that angle belongs in this triangle. So as we can see here, that K belongs in which triangle? MRK or MKR, okay? So we know without a shadow of a doubt that is a right angled triangle, but we'll have to account for that business, okay? So we can see here that this is 4 marks, so this is not child's play, okay? So this is the type of the NBT type of questions where you have to work your way from planning to explanations to a final calculation. So we can simply say in triangle MR, or let's just say MKR or KMR, whatever. This is the triangle of our interest because it makes our lives a lot easier. We should show some organization. What do we know, guys? We know for a fact that RME, for example, is equal to 90 degrees. Why? We know that the diagonals of a rhombus meet at right angles. They meet at a right angle. Okay, great. So that is a powerful statement. We're setting things up. Now, what else do we know? We also know that essentially MRK is going to be, maybe let's just do it this way without wasting time, tan of MRK is going to be equal to the gradient of FH, okay? That is its angle of inclination. This implies that tan of MRK is going to be equal to 1. Therefore, MRK is going to be arctan of 1, which is 45 degrees, okay? So that was an important intermediate step. We can say then we know for a fact that MRK plus the one that we want is, we said MRK, and what is this one? It's MKR, must give us RME. Okay, what is that? This is an exterior angle of a triangle. We've already explained what triangle we're working on. So you see, when you are a little bit organized, your life is easier. So this implies, what do we want? This is 45 degrees plus MKR, which is what we want, is equal to 90 degrees. We can say here, therefore, MKR is also going to be 45 degrees. Nice and easy. Of course, you can do an intermediate step if you want, but you don't want to say too much. Sometimes when you've said most of the things that are important, you are good. This was a critical issue here. That statement and its reason is important. This determination is important, okay? This substitution into an identifiable formula and the final answer is how you score those 4 marks. Great stuff. Otherwise, that reason is grade 9 stuff, so not really impressive. Okay, let's go on. 3.2. We are told to use the properties of a rhombus to calculate the value of P. Again, 4 marks. So these are questions you should also expect to see in the so-called NBT. Why? Because these are higher grade questions. They're not easy, because things are hidden here. So what can we use here? All we can use technically is the fact that, there's two things you can do here. No, you can't. Remember, the sides of the rhombus are all equal. Actually, I forgot that part. They are all equal. It's like a square that was squashed, okay? They are all equal, so you've got options here. You can essentially use the distance formula. Say that side is equal to that side, because all sides of a rhombus are equal. So you can do that using the distance formula, or you can use the fact that these are perpendicular. So the gradient of EM multiplied by the gradient of FH is equal to -1. So let's use that. It's a bit easier. So all we know is that, what do we know? We know that the gradient of EP, EM, multiplied by the gradient of FH is equal to -1. Why is that? We know that diagonals of a rhombus are perpendicular to each other. Easy. Easy, 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 easy. So this implies that the gradient of this one is going to be y at M minus y at E over y. I think here the formulas are going to waste our time, guys. Let's not do the formulas. We can just say this is going to be 3 minus P over, maybe let's just let the P be the leader. It doesn't matter anyway. 3 minus P over 2. Oh God, Uncle Sam, what am I doing now? What am I doing? So this is 2 minus 8, okay? And then here we've got 3 minus P is equal to, no, you are lying. Now remember that gradient was a 1. This is 1 over 1 is equal to -1. Okay, that's easy. How do I even need to do that? I don't, man. I can just put a 1 in there. This implies we cross multiply that stuff over there, because this is this one, and then we cross multiply. So what we've got here, 2 minus 8 is -6. Is equal to, this is now going to be -3 plus P. Okay, great stuff. So we can see here that when we transpose the -3, it becomes a +3. 6 plus -6 plus 3, it will tell us that our P is a -3. Does it make sense? Yes, it does, because it's a point just before point F. Okay, so we can accept that. So we're getting 4 marks. Again, this statement and its reason is important. That lovely calculation is important, and the entire substitution in general, and the final answer is where these marks are sitting. Ne. So you guys are flowing right. So let's do the next question. 3.3. We got to move. Calculate the coordinates of G. Now we can do it, because we can see that is the midpoint. So we can say, we know that G is such that x at G plus x at E over 2 should give us an x at M. Likewise, y at G plus y at E over 2 should give us a y at m. Again, we need to put a reason there. Why? We know that the diagonals of a rhombus bisect each other. At m, the reason is becoming longer. I don't like it. This implies that our g is the story that is like this: x at g minus 3 over 2 should give us a 3. Okay? Is 2y at g plus y at e, which is an 8 over 2, should give us a 2. Okay, we can make a conclusion. Therefore, g is the point. So we cross multiply the 2 there. So that's a 6. Ne? 6 plus 3, it's a 9. Is 2. Then we cross multiply that 2, we get a 4. 4 minus 8, it's a minus 4. 4 minus 8 is a minus 4. Ne? Yeah, it makes a bit of sense there, because we can see that point G is a point below point F. So that minus 4 looks correct in its position. At the same time, that point is just ahead of point H. The x-coordinate was an 8, so this is a 9. So essentially, this may be an issue of the values, but the position and those values are convincing, is it not? So essentially here we were scoring just 2 marks. So this is the substitution and the answer, but everything else cannot be ignored for word 2. So don't be lazy. Don't be lazy. 3.4. Okay, let's quickly finish up here. Now we're told here the rhombus is reflected about the line x is equal to minus 3. So where's that line? This is this line right here. Okay. Maybe let's make it a bit better. Okay. Yeah, it looks alright, man. Sometimes when you're drawing a line that does not exist, you want to break it apart into parts. Because we know here we have minus 3. So that is our pivot. That is our pivot point. So essentially, if we're reflecting this rhombus about this line, that means we're doing a horizontal reflection. So essentially, we're going to flip this rhombus to the other side. But now, what are we supposed to do? It says now n is the image of m, okay? So m is the image of m after the reflection. So calculate the length mn. So we've got to be smart. So how far is point m from that line? That is the key. So point m from that line is how far. So this is going to be a horizontal line, isn't it? So 3 minus 3 is going to be 6 units. Okay? Great. So when we reflect this across this line, we expect to see the same number of units on the other side. So we have 6 units also. So this is where n is going to be. Okay? So what would be the coordinates of n therefore? Well, we know that when we're doing a horizontal reflection, the y values don't change. So this is going to be 2 still. But now what about the x-coordinate? So essentially, we can just simply say we're moving this point to the left. How many units? 12 units. Nah. Yeah, doch. Is it 12? Let me think. So we're going to flip this. Yeah, this is going to be 3 minus 12. Yeah, 3 minus 12 gives us a -9. Okay, that's what we need. Or essentially you just add those two values, you are done, because mn is going to be that horizontal line is 6 plus 6, so that is fine. So if they said determine their coordinates, yeah, that would be the one. But now it's a big story. It's a big story. So it's just 3 marks. Again, it's one of those silly questions. They look simple, but it's not simple. You've got to be super careful when dealing with that question. Now, how are we going to do this? Well, we're going to say, let's look for the coordinates of n so that we make life easy for ourselves. We're going to say the rhombus is reflected horizontally about the line x is equal to -3. We can say therefore n is this point, -9 is to 2. Again, we are doing here by inspection, okay? It is by inspection. You don't want to think too much. You can say this, you can say then mn is going to be the square root of x at n, maybe let's say x at m minus x at n all squared plus y at m minus y at n squared. Okay, so let's do this thing. X at m is a 3 minus -9 is going to be +9 squared, plus this is the story of our lives, 2 plus 2 squared. Now this is basically 12 squared is 144. No, there's no plus here, there's a minus. I don't even know why I had to do this one. It's very silly, is it not? Yeah, doch. I should not have done it. I should not have done it, but it's okay. It's no crime at all. So this is basically 144. 144. The square root of 144 is 12 units. Okay, you can do whatever you want here. I've shown you some options. You can do a whole lot. Again, you will show this in your diagram because that's what matters. The other things don't. So technically, for me, this point is important. Ne? The substitution into the distance formula and the answer. So it kind of makes life a lot easier, but you can use other means necessary looking at that sketch. So we're taking our 17 marks with a smile, Bafowetso. And we move on. Let's try to press this one down quickly. So question 6 reads, in the diagram below, a circle centered at R, which those coordinates are given, so there's the center R, passes through the origin. Okay, so that's the point on the circumference of this circle. S and N, which is 6 is to Y, and okay, we can see now they wrote K instead. Then from P, a point outside the circle, tangents are drawn to O and N. Great. So what do we know? We know that tangents from the same point outside the circle to the same circle are of equal length. Okay, number 1. Number 2, we know that if we draw that line over there, we understand that that line should be perpendicular to that one because the tangent is perpendicular to radius. Likewise, that would be a similar story. if we draw that line over there, we will find that this should be perpendicular. I man, come on, okay, don't worry that it's slanting, but whatever. It's irritating me. I don't know why it's doing it. I don't want to lose time actually. Now we can see here that these are ready. So we've got ourselves a kite. Okay, not a problem. So let's go on. Skim and scan these questions, guys, before you answer. Of course, when you're practicing, but you know, you don't want to be caught out by silly things, so that you can see what approach you need. Okay, again, do this when you're practicing so that it becomes second nature, so that you can do it faster. Determine the equation of the circle in that form. Okay, not a problem. We know that the equation of circle center R is such that, okay, maybe let's write properly, is such that we know that x, when we see that is a positive, the x coordinate at the center, we put it negative, all squared. Then we're going to have y. Then again, the y value at that center is positive, so we're going to put it inside the bracket as negative is equal to r squared. Okay. Then we know that through point, the origin, okay, through point O, which is the origin, what do we see? It is going to be such that, what am I doing? Aibo. Through point O, which is the origin, what do we get? We get 0 minus 4 squared plus 0 minus 2 squared equals r squared. We can say, therefore, our r squared is going to be, this is 16 plus 4, that is 20. We can say, therefore, the equation is such that x minus 4 all squared plus y minus 2 all squared is equal to 20. That is the answer to that question. Nice and easy. No big deal is. That is important, and that was also important. I am trying to figure out what else is also important. I don't know, man. So maybe we can say this side, whatever, 3 marks in the bag. So you will check the official marking guidelines for an exact way of getting those marks. It says now calculate the value of k. Okay, so the value of k is going to be a bit of a situation, is it not? Because now we only need to use the distance formula for those already. Okay, great. So we know that, well, we can simply say nr squared is going to be equal to OR squared. Why? These are already I. But we want to use this to our advantage. This implies now this is going to be x at r. That's a 4 minus 0 all squared plus, what am I doing? So essentially, we want to say here 6 minus 4 all squared plus, we're going to say k minus 2 all squared is going to give us 4 minus 0 squared plus 2 minus 0 squared. Okay, easy stuff. This means we've got 6 minus 4, that's a 2. 2 squared is a 4. Leave this one alone. K minus 2 squared is equal to, now this one is a 4 squared, that's 16, plus 4, that is 20. Then this implies that k minus 2 all squared is going to be 16. Then we take the square root. And then what do we get? We get that k minus 2 is plus or minus 4. Okay? So essentially, we can say therefore k is going to be equal to, we take the positive one is going to be a 6, or k is going to be equal to, let's see, this is going to be minus 4 plus 2, that's minus 2. So it gives us the corresponding x coordinate. So that would be the 1, right? It would be at minus 2 there. But we're not interested in that, so we can just ignore the negative 1 because that's the answer that we wanted. We don't want too many problems. Easy stuff. So again here, I believe, how many marks were we scoring? 4. So this statement is important. Each substitution is important. And the final answer. Okay. The rest is your own problem. So 4.3 says determine the equation of NP in the linear fashion, standard fashion. Okay. So here we can see we're scoring a bit of marks, 5 marks. Okay, not a problem. So we know without a shadow of a doubt that the gradient of Pn multiplied by the gradient of NR should give us a minus 1, right? Why? We know that the tangent is perpendicular to radius. Ne? Easy, 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 easy. So this is the way of finding that gradient. So we know that, look, we want the gradient of Pn. So we know that gradient of Pn into, now this one is going to be the y values, right? So it's going to be 6 minus 2 divided by 6 minus 4. Is equal to minus 1. And then we can say, therefore, the gradient of Pn is going to be whatever that is. So this is going to be 4 divided by 2, which is a 2. So this one becomes minus a half. Of course, it's a negative gradient, so we can accept it. We can say then, we know that the line Pn is such that y is equal to minus a half of x plus c. And then we know that through point N, which we just found now, is like this. 6 is equal to minus a half into 6 plus c. We can say, therefore, our c is going to be, this is minus 3. When it goes that side, it becomes a 9. We can say, therefore, y is equal to minus a half of x plus 9. That's the equation of that line. Okay, easy stuff. Again, this is a very common question. Please, guys, don't get yourselves choking on this thing. It's too easy. 5 marks. First, let's see the gradient. Ne. Yeah, man. And then this substitution. Yes, yes, yes. And then this final equation. Very important. Again, this calculation on its own is important. So the 4th mark, and essentially that statement and reason is critical. Okay, easy 5 marks there. 4.4 says, it is further given that the equation of OP is y equals minus 2x. Okay, not a problem. Now we're told to calculate the coordinates of P. We know that at P, it is such that minus 2x is equal to, this equation we just found, minus a half of x plus c. And then we know that through point N, which we just found now, is like this. 6 is equal to minus a half into 6 plus c. We can say, therefore, our c is going to be, this is minus 3. When it goes that side, it becomes a 9. We can say, therefore, y is equal to minus a half of x plus c. And then we know that through point N, which we just found, minus a half of x plus 9. Okay, so essentially we take this one to the other side. This implies now minus 2 plus a half of x is going to give us minus 3 over 2x is equal to 9. We can say therefore our x is going to be, when we cross multiply the 2, then it becomes 18, divide by 3 to minus 6. Does it make sense? Yes, it's on the negative x-axis. Therefore, we know that y is also going to be, we take the easiest, is minus 2 into minus 6. This is going to be 12, okay? No problem. So again, it makes sense. We can say therefore P is the minus 6 is to 12, okay? We can accept it, even though the values can cause us a bit of a heartache. So essentially equating these two is important. Working out that x coordinate is important and working out that y coordinate is important. This is where they tell you answers don't necessarily give you marks, because you can see here we get the marks before we get to the answer. All right, great. So that was 4.4. Oops, let's move it. So this is now 4.4.1. So now let's see 4.4.2. Says the perimeter. So the perimeter is an open, it's an unfolded, so of this quadrilateral PNRO, and we can see there that that is a kite, but we have to explain a few things as we answer, because this is 4 marks, so you're not gonna faff around here. First of all, we're going to say, look, PN is equal to PO, okay? Why is that? These are tangents. From same point. Okay, easy stuff. Now we want to use the other one as a means to an end. So PO is going to be, it's going to be x at, say for example, O minus x at P all squared plus y at O minus y at P squared. And then we substitute here, this is 0 minus 6, that is plus 6 squared, plus this is again 0 minus 12. Okay, so this is gonna be a plus 12, hey? No, it's a minus 12. Definitely. So let's see here. Oops. Aibo. Let's go back to mode. Hey, sometimes these things are going to be seriously problematic. So this gives us a 6 root 5. Units, okay? Not a problem. So that is fine. Now, what else do we need? We need the radius. Did we calculate our radius at any point in time? We kind of tried, but our radius in any case of that circle is the square root of 20. The square root of 20. And the square root of 20 is 2 root 5, okay? So we also know that we know that OR is equal to RN, okay? These are ready, right? which is going to be the square root of 20. So we don't need to calculate that because we've determined that equation. So this is 2 root 5. Okay, easy stuff, easy stuff. We can say then the perimeter of P N R O is going to be 2 into 2 root 5 plus 2 into 6 root 5. Alright, so this is essentially 2 into 2 root 5 plus 2 into 6 root 5. Whew. This is basically 16 root 5. Again, they didn't tell us what to do here, so we can leave it there or do it to 2 decimal places. This is 35,78 units. So that's fine. So you can leave it here or you leave it there. But we're told if we're doing decimals, we must do it to 2 decimal places only. If you want to avoid it, you can just avoid it, okay? Not a problem. So let's move. What is the story here? This statement is powerful, right? The substitution into the formula. And that one was a means to an end, so we leave it alone. Again, calculating the radius is important. We already knew it from there. So 2 marks. And then this substitution here is important, and the final answer. So that's how we score those last those 4 marks. Hey, there's still more. I went. Are you trying to kill us? So this is 4.5. Okay, let's quickly get to it. It says another circle centered at T is drawn to touch the circle centered at R at S externally. Okay. So let's do it. Let's do it. So we've got okay, there it is. So this circle intersects the other one at S. Okay, all right. And we're told that the center of this circle is T, which is X is to Y. Okay, great. I told you the radii of both circles are equal in length. Okay, so that means if we are smart, we will take it from R through S to that one. Ne? Here we're trying to be very smart. Okay, so we're being told here that this line is equal to that line. So this means S is the midpoint of this line RT. Okay, so we're told to determine the coordinates of T. So that means we need our S as a surrogate there, right? We must find S because S will give us what we want. Again, it's a higher order question. You need to plan and do it smartly. So what we're going to say here, we know that S is such that we're just going to go on. Here we know that X is what we want, so it's minus 4 all squared plus Y is 0 minus 2 all squared equals 20. Again, why are we doing this? This is an x-intercept of circle center R. Ne? Sometimes you want to be comprehensive so that you can work your magic. So this implies that x minus 4 all squared plus this is 4 is equal to 20 implies that x minus 4 all squared is equal to 16. Then we do our famous gymnastics. And we will make the conclusion that x minus 4 is equal to plus or minus 4. Wow. Not a problem, not a problem, not a problem. So therefore we know that x at s is going to be equal to the positive 1. So here it's going to be 8. Ne? When we transpose this to the positive 1, it's going to be 8. So we are interested at the x coordinate there, but the y coordinate is 0 there. So we can say therefore s is the point 8 is to 0. That was our first attack of this question. We can simply say then we know that t is such that x at t plus x at r over 2 must give us x at s. Likewise, y at t plus y at r over 2 must give us y at s. Again, what is that? It is given. It is given that rs is equal to st. Not a problem. So it's nice questions that are given indirectly. This implies that t is the story there. So we've got x at t plus 4 over 2 is equal to 8. And then we've got y at t plus 2 over 2 must give us 0. Then you just cross multiply the 2 there and you transpose the 4. So this is going to be 16 minus 4, that is a 12. Okay? And then we transpose the 2, it's a 0. We transpose the other 2, we cross multiply the 2 there, becomes 0. We transpose the other 2, then we get a minus 2. That makes sense. It's a point in the fourth quadrant. It could be a matter of numbers, right? But we can see that is the point ahead of point S. So 12 is acceptable. Alright guys, so these questions take a bit of time. You can see you will not really just run here. You've got to be smart about your business. So we were getting 4 marks. So essentially, this substitution with all the reasons are very important, and finding that point S is also an important step. And then substituting into this, midpoint business and the final answer is how those 4 marks are arrived at, and we take our 23 marks with a big smile on our face. Okay. All right, so let's go to question 5. So this is trigonometry. This will include both grade 10, in fact, from grade 10, 11, and 12. Okay, so anything is expected there. So we can just start here. Question 5. Okay, so let's deal with question 5. Shenanigans. So it says, it is given that cos of p. So once you are given stuff like that, you've got to do it. No, then Antonio. So we've got 5.1, okay? We're given that cos of 26 degrees hypo is equal to p. So always show it as a ratio, right? And then this already tells you need to do a terminal arm diagram to sort yourself out. So this is x, that is y, That is the origin. And now 26 is an angle in the first quadrant. Okay, so this is going to be 90 degrees. Okay, so we know that this angle is our 26 degrees. So if that is 26, what should be the other one? The other one must be, the other one must be 64, right? 90 minus 26, yes. So this angle here must be 64 degrees right there, okay? So you always do all possible angles when you're dealing with trig. Then cos is defined as adjacent. Adjacent to 26 should be P. The hypotenuse side is 1, so that is a standard circle basically. And then we know that from Pythagoras, if we want the y squared, that is the story. Again, don't need second invitation here. X is basically P squared plus y squared is equal to 1. Okay, maybe let's say 1 squared. We can say therefore our y is on the positive y-axis, so it's going to be the positive square root of 1 minus p squared. That is important. Of course, in grade 12, we don't care to see that calculation. You can just come and write it here instead. If you show it, we accept, even though you may have not shown us how you got it. Okay, let's start answering some questions. So 5.1.1 says we need to determine sine of 26. Sine is opposite, so it's going to be the square root of 1 minus p squared all over 1, okay, which is basically the same thing. In fact, I should not even be writing it again. You know, I'm just being crazy. So, all right, so basically, we get a mark for the answer. And we get a mark from that calculation because we didn't know what that was. Nah, easy, 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 easy. 5.1.2 says 10 of 54, 154. Now we need to use reduction formulae. How is it related to the angles we have on our diagram? So let's say 180, because this is a second quadrant, so it's 180 minus 154. It gives us 26. So this is the same as 10 of 180. This is the 10 of 180 degrees minus 26 degrees. Yeah. Yes. And then we know 10 in the second quadrant is negative. Oh my goodness, what am I doing now? Okay, so this is a bit silly now. 10 is opposite of adjacent, so the opposite, wait, the sign, minus. So this is 1 minus p squared all over p, okay? Great, and there's no solving this one further, so we leave it like this. Great, so what do we do here? How many marks were we scoring? 3 marks. Maybe for this story right there, and then that story right there, and yeah, those 3 marks look nice like that. They look nice like that. So reduction formulae are always going to be there. So this one, we have to find sine of 13 degrees times cos of 13 degrees. So now this one is one of those lousy questions. Okay, they're not lousy, but they're silly. Okay, they're silly questions. So you ask yourself, how did you get this? But we know that 13 is half of 26. So this must be some sort of a double angle identity, ne? Yeah, man. So all we know is that we could easily say, okay, this was the question, ne? So don't write this, ne? Don't write it. So we know that to start off, we can say sine 26 degrees is going to be 2 sine 13 degrees times cos 13 degrees, isn't it? Double angle identity for sine. What did we get for sine 26? We got the square root of 1 minus p squared is equal to 2 times sine 13 degrees times cos of 13 degrees. Okay, easy stuff. So we divide by 2 throughout. So that and that cancels. We can say therefore sine 13 degrees times cos 13 degrees is going to be equal to the square root of 1 minus p squared all over 2. Okay, so this one was a bit of a higher order question, a thing that you should be expecting in your NBTs. Okay, guys, the NBTs is all these high order type of questions because your problem solving skills are being tested there. Can you plan and solve problems? So you need to be able to play with a lot of things. As you can see here, you're getting reduction formulae, you're getting, because this is what you would do in grade 10, right? This is what you would do in grade 11, reduction formulae. Double angle identities, that's metric. Do you get me? So you see all things are represented there. So here you're only getting 2 marks. My goodness. Lord of Lords. Basically, we're getting a mark for the substitution into that double angle identity, I guess. And the final answer. Wow, they are very stingy. Okay, guys, let's not waste time. 5.2. We're told to determine without using a calculator the value of the following expressions. Okay, great. 5.2.1. We've got cos of minus theta times the tangent of 180 degrees plus theta. Okay, divide by 2 times cos of 90 degrees plus theta. Okay, so by the way, when we're solving these, we're using this business here, BODMAS, or BODMAS in its true sense and applied. So the next thing we're going to do factorizations in all forms, highest common factor, trinomials, and difference of two squares. And then we're going to use identities. Okay, please, if you don't know what I'm talking about, you may want to have a look at some of the other videos I have done on paper 2. It will explain what that is. Okay, let's just keep going. Now, these are brackets off, which is essentially reduction formulae in application in trigonometry, or just simply BODMAS in arithmetic or algebra. So cos of a negative angle is always positive if that angle is acute. So theta is theoretically or in principle an acute angle. So this is positive cos. So we're doing reduction formula here. And then tan of 180 plus, that is the third quadrant. So tangent is positive there. Okay, we've got that over. Now we've got 2 into. Now 90 plus theta is the second quadrant. Cos is negative. But because of 90, we're going to use the cofunction of sine theta. Okay. Now we sort this out. So this is basically cos theta times, now we use identities here. So you see from that step, we come here. So 10 is basically sine of theta over cos of theta. Divide by basically minus 2 sine theta over 1. I like to expand these things so that I can make my life a lot easier. So this is basically sine of theta. When you flip this, it becomes multiplied by minus 1 on the top, 2 sine theta. And then the sine thetas do it. So this becomes minus a half. Okay? So you have to double check this type of questions because they will hurt you. So assign any value for theta and double check what is going on here. We've got cos of minus 2, for example, if we say theta is a 2 into 10 of 180 degrees plus 2, which is our theta. And then we're dividing this by 2 into cos of 90 plus 2, okay? So what do I get? I get minus a half. So then that means my work is good. So that is me and you using the doctor's approach. Again, we get a mark for that positive cos, we get a mark for that positive 10 and that minus sine. So those are the 3 marks in the bag right there. Then using the 10 identity there, we get our 4th mark and we get our 5th mark right at the end. So easy 5 marks there. So we've got 5.2.2. And then we are given here 1 plus 2 cos 105 degrees times sine of 15 degrees. Okay, so how do we solve this? This is 1 plus 2 cos. Now we need to use reduction formula here. So 105 is basically 90 degrees plus 15 degrees times sine of 15 degrees. Okay, always try to make it look like what you've got. Although this is a higher order question as well, because it's not quite obvious, it can cause a few problems. This is now plus 2 into, now we solve this using our reduction formula, BODMAS, or brackets off. So 90 plus 15 essentially is in the second quadrant, and cos is negative, but now the co-ratio is going to be minus sine 15 degrees times sine 15 degrees. So this is basically 1 minus 2, then it's going to be sine squared 15, sine squared 15 degrees, because sine 15 times sine 15 is sine squared 15. What does this look like? This looks like the double angle identity for cos 2 into 15 degrees, which is cos 30 degrees. Now we know that cos of 30 is basically root 3 over 2 from special angles, okay? All right, again, you want to double check this business right here by just punching that thing in the calculator. So it's 1 plus 2 into cos of 105 degrees into sine of 15. So we get root 3 over 2. So it is correct. So you cannot lose these marks, guys, because you've got skills on how to deal with this. So essentially we are sorted. So do you see we again used BODMAS by taking that bracket using reduction formulae, and then as we solved we got to a double angle identity, and we solved further using all the stuff that is in there. So how many marks are we scoring here? 4 marks. All right, first of all, knowing that this is going to be minus sine of 15 is important, and then recognizing that that would be a double angle identity is important. And essentially this is important on its own. I would imagine this step is critical, right? So this is where those 4 marks are, I believe. So let's do 5.3. Okay, 5.3 says consider that trig equation or identity. So we've got 5.3.1. It says now prove the identity. So we know that the left hand side is more complicated. Always choose the more complicated side. 1 minus cos 2x minus sine x all over sine 2x minus cos x. Okay, this is equal to, now we use our BODMAS factorizations identities. When you look here, we don't have any we don't have any brackets, we don't have any like terms, we don't cancel anything out. So can we factorize? No, we can't factorize anything as yet. Identities, the answer is yes, we can use identities here, because we've got 1 minus the cos double angle identity, but because of this guy sine, we want it to look like it, so it's going to be 1 minus 2 sine x, sine squared x, sorry, minus sine x all over, again we've got a double angle identity, so this is going to be 2 sine x cos x minus cos x. Okay, easy stuff. We keep going, then we sort stuff out. 1 minus 1 is a 0, minus times minus is a positive, so it's a 2 sine squared x minus sine x over 2 sine x cos x minus cos x. Okay, so now the question is, after identities and cleaning up, what do? We can factorize. So do you see, we can factorize here by taking the highest common factor, which is basically sine x for the numerator. What we remain with is 2 sine x minus 1 over, on the denominator, the highest common factor is cos x into 2 sine x minus 1. And then these guys do it. And then we know that from using our identities again, sine over cos for the same angle, this is the same as tan of x. And okay, maybe let's not write it there, it's not correct like this. So we can say this is the same as tan of x, which is the same as the right hand side, is it not? Yes, we've proven our identity there. Easy. So you'll be playing around these things, flip-flopping between those 3 steps. Okay, let's see, what did we do here? Using that double angle identity for cos is important, and using the double angle identity for sine is important. And then the other issue now is factorizing the numerator and factorizing the denominator. That is also important. So perhaps we can just simply say anyway, just for factorizations in general, we get those marks, and then cancelling the factors is just a skill. And then knowing that that over that is 10 of x is probably where the fourth mark comes. Nah. Nice and easy, nice and easy, nice and easy. So we've got 5.3.2. It says now, for which value or values of x in the interval. Okay, now once we're given interval, we need to solve. Okay, we need to solve. Okay, for which value or values of x in the interval minus 180 to 180 is the identity not valid? When is it not valid? It means the denominator must be equal to 0. If the denominator is equal to 0, then the function is undefined. All right. So if it is undefined, that's when we say it's not valid. This is the case when we know that sine 2x minus cos I minus 10 is equal to 0, because division by 0 is undefined. Okay, so we can continue. This implies that 2 sine x times cos x minus cos x is equal to 0. We factorize this business here. We know that this is cos x into 2 sine x minus 1 is equal to 0. This is more like the quadratic equations. This implies that cos x is equal to 0, or sine x is a half. Nah. Yes, and then what do we do now? We solve further. This implies that x is going to be plus or minus arc cos of 0, right? Plus k times 360 degrees, okay? Or x is going to be arc sine of a half plus k times 360 degrees, or x is going to be 180 degrees. For sine, you do two solutions. Okay, where k is an element of integers. So we are sorted. So can you see, this is all difficult stuff. So basically from here I can tell you this is very easy. I can easily say therefore x must to can be equal to alright, arc cos of 0 is basically plus or minus 90 degrees. Plus now k times 360 degrees, or x must be arc sine of a half is 30 degrees plus k times 360 degrees, or x must be, so 180 minus 30 is 150 degrees plus k times 360 degrees, where k is an element of integers. All right, great. We can say now therefore x is an element of what? Let's see. Now we can see that technically minus 90 is within that domain of minus 180 and wara. So basically this is minus 90 degrees. This is when k is 0, because when you're putting it, then it's going to be 30. We're just putting them in ascending order, and then it's going to be 90 degrees, and then it's going to be 150 degrees. And then we've exhausted our domain. This is when k is equal to 0. in our lovely expression. Okay, I don't know if you have to mention that, but I doubt. It's just me giving you extra information. All was necessary was essentially those solutions. So can you see, it's just 3 marks. I don't know if there's an easier way than that, but for 3 marks you are bleeding to death. Okay, these are the so-called, again, higher order questions. They are hiding the fact that you've got to work hard for this one by just giving you smaller marks to make you break your brain trying to find an easy solution. Do not think all questions are going to have a short solution just because they have got 3 marks. But what matters is that they know from above you've already worked out all those factorizations. So what they care about is this step. Cos 0 sine x being a half. That's where it comes, okay? And then, essentially, what matters again is this general solution. That general solution there. Wait, no. All of them general solutions. You see, they all get 1 mark. And then you get 1 mark for the final answer for getting all those values. Can you see? It's silly. It's silly. Unless there is something I am missing. Sometimes you think you understand the question only to find that you are the one who's lost. Okay, so it says find the general solution for whatever we've got there. So we've got sine squared x plus 2 sine x cos x is equal to 3 cos squared x. Okay, great. So when we inspect this expression, we're like, okay, we've got a square here. And then we've got another square here. And we've got an expression in between that has both cos and sine. Then this is a trinomial, is it not? So let's attempt showing it as such. So this is sine squared x plus 2 sine x cos x minus 3 cos squared x is equal to 0. This is more of a quadratic. So let's see if we cannot factorize this thing grade 10 style. Now we've got sine x, and then now we can get here 3 cos x and cos x. But now this one must be positive, that one must be negative, and it looks fine. So we can say this implies that sine x is equal to cos x, or sine x is equal to minus 3 cos x. Great. So here we can see we can just simply divide by cos x. And then that happens. This implies that, oops. Now sine over cos, we're using our identities. So can you see, anyway, what did we do here? We started with factorizations. So can you see all of these things work together? We factorized and then we solved. Then we are simply sitting at identities now, right? Because now sine over cos for the same angle is a tan of that angle. Now this is equal to 1, or again this is tan x is equal to minus 3. Great. Now we want to do the general solutions. So we know that this implies that x is equal to arctan of 1 plus k times, now the period for 10 is 180, or x is going to be equal to arc10 of minus 3. So here you just consider one solution because it repeats itself every 180 degrees. So where k is an element of integers. So we can make a conclusion because now we're doing general solutions. X is going to be arc10 of 1 is 45 degrees plus k times 180 degrees, or x is going to be, now I need a calculator for that one, so shift 10 of minus 3. So this is minus 71 comma to 2 decimal places 57 degrees plus k times 180 degrees, where k is an element of integers. So here we're doing just general solutions, so that's it. That's it. So this is easy. So do you see here? There's a lot of things. So we started with factorizations, we ended up with identities. Please guys, this is something I would suggest you look at closely. Take all these trig expressions, be it identities, play with this, you will see how useful it is. Instead of going all lost, again, use your inspections before you start solving. Otherwise, you will solve what you don't understand. Now, we're getting 7 marks. All right, so I guess for this factorization, it's definitely a mark. Okay. And then for each of these solutions, it's definitely a mark. All right, and then for this general solutions, definitely a mark. So we've got 1, 2, 3, 4, 5. Maybe 6 for putting it in standard order. I mean, sometimes the marks are very crazy where they are. And perhaps for using these identities at some point, perhaps 1, 2, 1, 2, 3, 4, 5, 6, 7. I don't know really where those marks are, but wherever they are, it's not a big deal. So we've got 30 marks, so we know. We solved it, hopefully. Let's move on to the functions. This is now, a tough one. This is a tough one. Okay, it's not tough, it's the easiest of all trigonometric issues. Okay, let's look at it. Sketched below is the graph of f of x equals cos of x over 3. So this is basically suggesting that f of x is basically cos of a third of x. It's much easier when you simplify things. So please be in the habit of inspecting things. Okay, what do we see now? We can see here that we've got an invisible 1 as the coefficient of the function. So what does that translate to? So that tells us our amplitude is a 1, giving us a minimum of -1 and a maximum of +1. And we can see here it's already the case. The maximum is at 1. Okay, all right. Now the next thing here is the coefficient of our angle. Okay, it is also giving us a story that the period is going to be the standard 360 degrees for cos divided by a third, which will give us, so let's see, 360 divided by a third is basically 1080 degrees. Okay, now what would be our workhorse here? Our workhorse is going to be any x value in the original cosine graph divided by a third. Okay, so this is what is going to help us deal with our critical values. Okay, So those are the critical values that we should always know. Okay, the other issue is the issue of intervals. The intervals will always take the period, which is now 1080. We divide it by 4. Okay, so why we divide by 4? There's 4 quadrants that we draw these graphs for. Okay, so the intervals is the period divided by 4. What is that? 1080 divided by 4 gives us 270. So this means from one critical value to the next is going to be an interval of 270 degrees. This simply says, as you can see, the first interval, the first critical value is going to be the original, which was a 0, divided by that, which is a 0, and that should give us a 1. And there it is. So the next one is going to be at 270. So this intercept will be at 270. Okay. So that is the story. Okay. Let's leave the rest. So now it says on the grid given in the answer book. Okay. Now we're told there is a grid somewhere. Draw the graph of g of x is equal to sine of x plus 1. So basically all we can see here, this is the standard sine graph shifted vertically up by 1 unit. Okay, so otherwise the critical values don't change. It's just that their vertical position is what changes. Okay, so let's do question 6, nice and easy. So question 6 says we have to look for that graph. Maybe let's just look. Okay, so we've got our graph right there. So now we need to find stuff. Okay, so here it's very easy because the critical values for sine are the same. Now let's see. We've got the first one is 0, right? So 0, sine of 0 is a 0. Then we add 1. So this one goes to 1 over there. Then sine of 90 is a 1. Ne? Sine of 90 is a 1. Then we add a 1. It goes to a 2. Okay, sometimes these ones are a bit silly. Just to get it right is a bit difficult, okay? So we see there that there is a 2 there. Okay? And then sine of 180 is a 0. Then 0 plus 1 is a 1. So again, we've got ourselves a situation here. So we've got ourselves a situation. So we see there is a 1. Of course, I'm just going to approximate things now. Okay, so that is it for this side. Then again, sine of 90 is a minus 1. Minus 1 plus 1 takes us to exactly 0. Okay, and then sine of minus 180 is a 0, and then we add a 1. That one takes us to stuff like this. So sometimes these questions can overwhelm you. You just need to be comfortable with this, okay? So other things were a means to an end. We can remove them because this was not a proper grid. It's always nice when they give a proper grid. I don't know why they don't. So there it is. So we're going to label it G. And then the other one was an F graph. Okay. So we're good. We're good. So how many marks we're getting? 3 marks. So maybe for one of the intercepts, be it an X or a Y intercept, you get a mark for that. For one of the turning points. And for the shape of the graph. So those are the 3 marks, okay? So let's do 6.2. We've got 6.2.1. It says now write down. So this one is easy. We are writing down. So write down the period of f. We already worked it out that this is going to be 1080. So you walk away with your mark over there. 6.2.2. The range of g of x minus 3. So we know that the range is going to be equal to the set of y values such that y is less than or equal to. Now the initial maximum was a 1. Then we're taking 3 from that. And then this should be greater than or equal to. The minimum was a minus 1 and we're taking 3 from that. Easy. So this is what your answer should be. So this is going to be minus 2, minus 4. Okay. Obviously, this is just your thought process. What should appear is this one, the final answer. Okay. Great. So you're getting 2 marks for working out those guys right there. Okay. So now 6.3. It says determine the maximum distance between the graph of g and the graph of h of x, where h is the reflection of g in the x-axis for that interval. Obviously, that would mean this turning point, if we're reflecting it, this turning point should be sitting at 0 right here. And that one should be going to 1 over there. No, to 2. Okay? So our reflection would look stuff like this. Okay. So it would look something like that. And so the maximum distance is just going to be 2 units. Again, if it says determine, it's a bit of a situation, is it not? So I'll just say 2 units here. Of course, you show on the graph what you did, so you should get 2 marks. A determination can be by inspection. So you will show this one, perhaps in a broken fashion, to show that that was not the big thing, but it was more of, you can say, g prime, or maybe the reflection of g. But you see, prime is difficult, it's dangerous, so I don't know, what do we say when it's a mirror image? Whatever, man, whatever. We don't have time. So that was a means to an end after all. So you do show that, I don't know, say the reflection. Maybe we can say giraffe to suggest a reflection. Anyway, so that's it. Easy 2 marks, and then we've got 6.4. It says for which values of x in the interval that was given is g of x multiplied, f of x multiplied by g of x. So now what does this mean? This means the y values of f multiplied by the gradients, because this is g prime of x, should be greater than 0. This can only happen if this one is positive and that one is positive. Okay? Or when this one is negative and this one is also negative. Okay? But now when we look at our graph, this guy is never negative. It's all above the x-axis, so it's positive. So this possibility is altogether not to be considered. So this is what we want. So we want positive gradients for g and positive y values for f, which we already see that for f, it's already positive. Then the positive gradients for g are in this fashion. You see, that is a positive gradient. That is a positive gradient, okay? So these others are negative gradients, so we're not going to consider them. So this means our interval is between 90, minus 90, sorry, and 90, but those ones are not included because the gradients are 0 there, so we connect them with a bar. Nice and easy. So we can say here x must be less than 90 degrees but greater than minus 90 degrees. That's what we see. So you get a mark for 2 marks for that notation, essentially. All right. So 6.5, I can write it there, even though it's not allowed, but I'll write it here, 6.5. It says the graph of G undergoes a transformation to form a new graph of K of X So now K of X, you can see here, we have oh, come on thing, don't irritate me now. So we can see here that K of X here, we've got a minus 15 degrees. We initially had just X. Now we are subtracting 15. That means we're shifting it to the right horizontally by 15 degrees. And then we've lost that one. That means we shifted it down by 1 unit. So if we describe, we can say here K of X is G of X shifted to the right by 15 degrees and downward. What is that? What is that? Downwards by 1 unit. Okay, easy stuff. So you get your 2 marks for that description, and we walk away with our 12 marks. Nice and easy, nice and easy, nice and easy. Okay guys, so let's move. Question 7, it's, question 7. So question 7 is that 3D structure. So we're told in the diagram below, TP represents a height. So a height is perpendicular to the surface, right? The foot of the building T and the points Q and R are in the same horizontal plane. Once you see something like that, you will see a shaded area. Almost always it represents a horizontal plane, and we can see that vertical is shown there. So from Q, the angle of elevation to the top of the building is 60 degrees. It's also drawn in. PQR equals 150, drawn in. And so QPR is X, it's also drawn in. And the distance between P and R is 300 meters. So that is shown. Okay, so we don't need to draw anything in. So we start answering. 7.1 says write down R in terms of X. So it's just 1 mark. So you can see here that this is a triangle. So from 3 angles of a triangle, we know that angle P in that triangle PQR, angle P plus angle Q plus angle R should be 180 degrees. Again, sum of 3 angles of a triangle. So this means that R is going to be equal to 180 degrees minus 150 degrees minus x, which is just 30 degrees minus x. So they said write down. So now we're just going to write it down that angle R is equal to 30 degrees minus x. So we just get our 1 mark. 7.2 says determine the length of PQ in terms of x. Now we can say safely in triangle PQR, because we can see that is good enough to work. So let's see, we want PQ over, we can use the sine rule. So PQ is opposite angle R. Okay, so we're going to say sine of angle R. We've stated which triangle we're working with, so we don't need those compound words there. Again is equal to, now we can see here that technically this is the story. That's 300, which is PR, over sine of angle Q, because we always want stuff that we know. So what are we doing here? This is the sine rule. Okay, nothing serious. This implies that PQ, so just simply cross multiply that, is going to be PR, which is 300 times sine of R. We saw that this is 30 degrees minus x. Over sine of Q. This is sine of 150 degrees. Great. So sine of 150 is basically a half. So basically this is the same as 300 times sine of 30 degrees minus x over a half. So this becomes 600 times sine of 30 degrees minus x. I'm overly simplifying, guys. I don't know if it is necessary, but let's just do it so that we don't suffer too much. So let's do 7.3. 7.3 says show that TP is this expression. Okay, easy stuff. Now we can see that we've just worked out that side, and in this triangle we want the opposite side of an angle that we know. We've just worked out the adjacent side over there. So we can say in triangle PQT, what is the story there? We know that spells out tangent. Tan Q is going to be the opposite TP over PQ. Okay, that's just basic trigonometry. This implies that tan of 60 degrees is equal to TP, which is what we want, over PQ. Now is this business here, 600 times sine of 30 degrees minus x. Okay, great. So that is over 1. So we can cross multiply that there. So we can say therefore TP is going to be tan of 60 degrees times 600 times sine of 30 degrees minus x. What am I doing? What am I doing? Now from special angles 1060 we know that it's root 3 ne? Times 600 into, now we can expand this using compound angle identities because we don't have a choice now. So it's going to be sine 30 degrees cos x, the negative doesn't change, as cos 30 degrees times sine x ne? Root 3 times 600 into sine 30 is a half, cos x minus cos 30 is root 3 over 2 sine x from special angles. And we FOIL stuff out, or what we can do, we can see that half is still a common factor there, right? Because we want it to look like that. So we are going to get ourselves here. We can put the number in front, 600 root 3, and then we factor out a half here, times a half into, now we get cos x here minus root 3 sine x. So we know that this dude will do a number to that one, so that we have 300 root 3 into cos x minus root 3 sine x. Okay, and that's it. That's it, guys. We've proven it. Nice and easy. Nice and easy, nice and easy. So again here, for this type of questions, you still need one BODMAS, both in its true sense and applied in trigonometry. You need to factorize, okay? And you need identities, okay? So you will see the utility of this business. As you keep looking through, you will see that if you follow what we did here, we did all of that. Okay, guys, let me drink some water. All right, so where are the marks? Technically, this substitution is the story. That is the story. And then this expansion is the story. All right. All right. And using the special angles at this step is the story. Okay. All right. And then factoring that half is the story. The rest was already given, so you're not going to get a mark for it. Now let's go to Euclidean geometry. So this is always going to be the easiest question. Question 8. So we've got question 8 over here. Let's start. And let's move as quick as possible. So we're told in the diagram PRQT is a cyclic quadrilateral. Okay, so there is that dude. Okay, let's just outline it, because sometimes when diagrams are, are made a little bit complicated, they create a bit of situations for you and I. So we can see there is our cyclic quad. I'm just trying to be complete. Otherwise, I don't need to be doing that. But they're already telling us that this side QR is equal to the side QT, suggesting that if we actually divide this line right through the center, right through this line here, because this is produced, I'm sure, yeah, chord RT is produced to S, right? That's it. we can see there that we will find that these angles should be equal as a result. Ne? Yebo. The reason is these are base angles of an isosceles triangle, or nowadays you call it angles opposite equal sides. Okay, and then we simply know that if we've got 146 on the outside, these are angles on a straight line, so we can actually find this angle. If we find that angle, we have that angle R1. And using those two angles, we can find this angle right here. Okay? Angle Q. Ne. That's number one. Number two, we know that this angle right here is going to be twice that angle. Right angle at center is twice angle at circumference. Easy. Let's just read now. In the circle QR is equal to QT, we've already done that and worked out things. Chord RT is produced to S, we already saw it. And radii OP and OT are drawn. And then PRT is 42 degrees and QTS is 146. So we could see that. And then again, we could add some info there that this dude and that dude should be equal. Those are ready. Those are ready. Okay. If they are ready, this suggests that this angle is equal to A. Yeah, is equal to that other angle. I went superb. Okay, so there's a bit of a complicated situation there. Sometimes you don't like to make it too complicated. You would rather keep it simple. So let's see. Determine, giving reasons, the size of the following angles POT. We've sorted it out. So you see, when you analyze, you already have answers nice and easy. So we know that POT is going to be equal to 2 times angle PRT. Again, we know that angle at center is equal to 2 times angle at circumference. Okay, great. So let's deal with it. So this is 2 into 42 degrees, which is now 84 degrees. So that statement and its reason and the answer. Usually this is 3 marks, but we don't want to complain. Okay, we want R1. R1 is easy because we're going to have to use those angles on a straight line and. Okay, so first of all, we're going to say angle R. Angle Q TR plus angle Q TS is equal to 180 degrees. Okay, these are angles on a straight line. Okay, easy. So this implies that angle QTR plus 146 degrees is equal to 180 degrees. Therefore, QTR is equal to you know, 180 minus 146. I don't know why I'm thinking now 180 minus 146. Actually, my brain is thinking. But I think this statement was not quite, I think this statement was not quite. We can say but what? We know that angle R1 is equal to angle QTR, which is the story that says these are angles opposite equal sides. It is given that QR is equal to QT in triangle RQT. Okay, I'm trying to be as comprehensive as possible. We can say therefore angle R1 is 34 degrees. Of course, can you see here they're hiding, they're just giving you 2 marks, but there is so much work for you to do there. But yeah, what can we do? Nothing. So what about this story now? Essentially, this is important and that is important. Nazi ingxaki. Yeah, we can't mark that 34 again. Okay, yeah, that's it. Sometimes you are told answers do not necessarily give you marks, so you should go on without looking back. RPT, RPT. So we want this whole angle. But we know that this angle and that angle will add up to 180 degrees. Ne? Because these are opposite angles of a cyclic quad. Our key is finding Q. And we can find Q in that triangle. Fine. We know that technically that angle Q plus angle R1 plus angle QTR is equal to 180 degrees. Again, this is sum of 3 angles of triangle RQT. Great, so we want Q here. So Q plus R1, which we found to be 34 degrees, plus this one is also 34 degrees, is equal to 180 degrees. Therefore, Q is going to be 180 degrees minus so this is 112 degrees. Okay, that was a means to an end. We've got a story here, but we know that angle Q plus that angle RPT must give us 180 degrees. These are opposite angles of a cyclic quad. We've already been told what quad it was. Sometimes it's nicer to mention it though. This implies that 112 degrees plus RPT is equal to 180 degrees. Therefore, RPT is going to be 180 Something is not making sense though. But anyway, let's see. So RPT is 180 degrees minus 112, which is 68. Whew. Okay, let's see. But you see, the diagram they told you though, it's not drawn to scale. So it's easy to make a mistake and say that angle there is obtuse while that other angle is acute, okay? But it's actually the other way around. Wow, that's ridiculous, but that's how it is. So we move on. Okay, so basically finding Q was key to the story, and then this statement and its reason is important, and the final answer. Okay, so we take the 7 marks. This was always a warm-up. Okay, this question is a warm-up. So let's do question 9. All right, question 9 says in the diagram, 2 circles touch internally at M. Okay, MK is a common tangent, so that is an important statement. That is an important statement to the circles, right? Right, so let's see. You say a common bug. So let's highlight him. A, E, and C are points on the larger circle. Okay, so A, E, and C are points on the larger circle. So that means those points are concyclic. So if we were to form a quadrilateral there, it would be a cyclic quad. Okay, together with M. Okay. Okay, and B and D are points on the smaller circle. So that's fine. B, D, and M as points on are the points on the smaller circle. So those are also concyclic. Okay, not a problem. Now chord CA is produced to meet tangent. Chord CA is produced to meet the tangent at K. Okay. So there is CA. And is produced to meet the tangent at K. Okay. And then what else do we know? We also know that triangle MEC, wow, the MEC of health, right? Minister of what? Whatever. Anyway, MEC is drawn. Okay. Triangle MEC is drawn, so we can see that. All right. So there's our triangle MEC. We've seen it. Okay, so what do we see now? CA and EM meet at B. Yeah, we can see that. CA and EM, they meet there. Not a problem. And then KB is a tangent. Whoa, there's so much information here. KB is a tangent to the smaller circle at B. Okay. Whew, yeah. So we can see that. And then D is a point on CM. Yes. AM and BD are drawn, yeah. So let KMB be equal to X. So this is this angle right here. Okay, we made this one equal to X. Great. So what can we do? Okay, don't answer questions here if you have not done your homework. So you need to know what to do. I hate these questions. Yeah. Okay, we're about to be done. Not a problem. Let's move. It says now, if that is x, the tan-cot theorem tells us that that angle there should be this angle. Okay, so that angle C1 plus 2 should be equal to angle x. That's the tan-cot theorem, which is also the same angle as this one. Again, tan-cot theorem, because that tangent was common to both circles. So we can see that if these two angles are equal and they are forming that letter F, that side must be parallel to that side. That is just an extrapolation. Is it interpolation or is it extrapolation? Whatever. That is just an interpretation or interpretation. So essentially, this would tell us that then this guy is equal to that guy as well. Those are corresponding angles. Great. But we also know that that angle is equal to that angle over there. Why? Those are angles in the same segment in the bigger circle subtended by chord CM or arc CM. Is there more we can do? At this point, it is safer to just stop. Okay? Let's just start working before we lose time. Sometimes you don't want to do too much. Now it says name giving reasons for other angles, each equal to x. Okay, so we will see what to do about that story. We will see what we're going to do. So 9.1. Now we have to first think. We know that C, okay, maybe we can say D1 is equal to, what was this angle called? KMB is equal to KMB equal to x. What is the reason here? That is the tan-cot theorem. Okay, easy. That's number one. Number two, what do we need? We need to connect C1 plus 2. So C1 plus C2 together is also equal to KMB equals x again. Tan-cot theorem. So those are marks. Okay, the statement and its answer are a mark. And its reason are a mark. Okay, let's find another one. What are we going to do now? We have got a huge task. Yeah, man, let's have a look, see. Okay, so let's have a look. So essentially, if we look again in the small circle, this is still a tan-cot because we're told that this is a tangent to this circle. And of course, if that is a tangent, tangents from the same point outside that small circle should be equal. So you can either use that or we can use the tan-cot theorem. So let's just keep it simple. So we know that, all right, B1 is going to be equal to D1. Since D1 is equal to x, so that is it. So what is this? Yeah, we look like children, ne? 10 chord theorem, 10 chord theorem. Yes, it must be if it is. Why do we want to complicate our lives? Again, if we look here, this is vertically opposite that angle. Sorry, so we know that B4 is equal to B1. Since B1 has been proved above to be X, but now these are vertically opposite angles. Oh, yeah. There's nothing more to say. So for each statement is important. So everything is connected nice and easy. So this is an easy 5 marks, guys. Wow. But why 5 now? Why 5 marks? This should be 4 marks, man. There's an error somewhere. This is usually just 4. Okay, prove giving reasons that 9.2.2 okay, now prove giving reasons that BD is parallel to EC. We did prove it. We can say we know without a shadow of a doubt that essentially angle C1 plus angle C2 together are equal to angle D1. Okay? Which, okay, maybe let's leave that one and say this one is, we can say each is equal to KMB. Now, we can see that above even, so we can make a conclusion, therefore, that BD must be parallel to the Eastern Cape. Why? This is now converse of corresponding angles. Is there such a thing that says converse of corresponding angles? I don't know, but if we prove corresponding angles to be equal, conversely, the lines are parallel that are involved. Nah, I believe so. So, essentially, this is the mark and that is the mark. Nah. 9.2.2. Yeah, I can feel the tightness now. Prove that angle A2 is equal to angle B2. We did it. You see, angle A2 is equal to that. Angles in the same segment, subtended by chord CM in the bigger circle, but therefore E is going to be equal to B2. These are corresponding angles with these lines proved parallel just above. Therefore, those two will be equal. So easy 3 marks now. So what we can say here is that, well, we know that angle A2 is definitely equal to angle E. These are angles in the same segment, subtended by chord CM. I think it's important to mention what chord is subtending them, because yay, you could be seeing flies, is it not? Okay, so we've got a but. What do we know? We know that angle E is equal to angle B2. These are corresponding angles with BD parallel to EC. Okay. All right. Okay, so we can make a conclusion and say, therefore, A2 is equal to B2. Okay. We can say each is equal to angle E. Great stuff. So that is the link between those two. So we're getting 3 marks. So this was a strong statement essentially. And then that is also a strong statement, and it's a strong statement, and that's it. Okay, let's do 9.2.3. We are then asked to prove this. Now, this is a bit of a situation, but if you look at ME, where's ME? ME is this side. No, man, stop doing things you're not asked when. ME is this side. Okay, so look at that. It is a side of triangle CME. Okay, we've got MD. MD is this side right here. Okay, it's a portion of that triangle CME. And then we've got MC. MC is this side, so we're messing it up now. We are messing it up greatly. So we can see that anyway, we're looking at triangle CME indeed, because now there is what? MB. So MB is this side. Okay, we can see here that we are dealing with that triangle, and we can see that on that triangle we have a line BD drawn parallel to the third side. It should cut the others in proportion. So that is just the proportionality theorem that we need to set up. So we can just simply say in triangle CME, what can we see? We can tell without a shadow of a doubt that ME over, now we can decide, we divide by MB. Okay, it doesn't really matter what we do, or say MD wara is equal to, now we started with ME, which is the big side, so it's going to be MC over the smaller side, which is MD. What is that? This is the prop theorem with BD parallel to EC. Yeah, and then we just simply cross multiply things here. Therefore, ME multiplied by MD is going to be equal to MC multiplied by MB. That's it. That's it. So essentially, that is the story. The statement and the reason, I think, because the rest is just connected to that. So we take our 12 marks and we run with it. Yeah. Okay, guys, so we move on. Now, guys, question 10 is going to be grade 12 related material now, entirely. So, I am not going to do 10.1, guys. This is stuff you need to know, and it's in your textbooks. There's nothing special in how I solve this. So all you need to do here is to just do a construction, okay, so that this angle is equal to that, and then whatever that spade, that tsinsi must be equal to the other tsinsi there. And this side must be equal to that side, and this side must be equal to that side. You understand? Now, once you take that triangle and you put it in the, what happens? Then now you're going to prove corresponding angles. That spade or tsintsiani, you know, the dot and the dot. So that simply says these lines are parallel. Once you conclude that those lines are parallel, you're actually approaching this one via the converse. Is it the converse? No. You just are going to use the proportionality theorem eventually to do what you've got to do. So please, guys, this is too easy. I'm not wasting my time on that. Okay, let's go for 10.2, which is what may be challenging. Perhaps, we don't know. We'll find out. Now, what are we told here? In the diagram, AB is a diameter. So once you're told the diameter of a circle centered at O, so this is the diameter. So what do we know about a diameter? It subtends a right angle at circumference. All right, not a problem. That's number one. And then I told you triangle ABS is drawn. ABS is drawn with S, okay? So we've got our triangle ABS, and then we're told here S is a point on the circle, yes. M is a point on MBS, and OM is produced to T, okay? So when a line is produced, it simply means we've got the same straight line, meaning that whole line is a straight line, okay? Okay, let's just reassure that those parallelities are not lost, okay? So, such that AS is parallel to OM, okay? Now, TS is drawn such that, TS is drawn such that BOST is a cyclic quadrilateral. So now, since these ones are not drawn in, we're just going to draw them. What is that now? Highway man. Eh. Okay. I think let's just remove this thing. All right, so if this is a cyclic quad, let's just forget about other things. If this is a cyclic quad, simply this means these are angles in the same segment subtended by the same chord OS. They should be equal, as well as these angles are in the same segment subtended by the chord TB or BT. That's what we can gather, because sometimes to draw things here is going to be a bit of a situation, right? Right. So we want to leave it here before it kills us. Okay? So if this line is parallel to that, this already tells us that we have 90 degrees also here. Those are co-interior angles. Or you can look at that one as what we call alternate angles. Or you can look on the other one as corresponding angles. There's plenty of ways of looking at that. But now I think we are ready to start working on our diagram. On our questions, sorry. So we're going to be doing 10.2. So we've got 10.2.1. It says now prove giving reasons that TS is a tangent to circle at S. So TS is a tangent to the circle at S. Okay, all right, okay. So we need to be smart. So if this is a tangent, we need to prove that this angle is equal to that angle. So we need to prove that this angle is equal to that. If we can prove that 10 chord theorem, we are, in good spirit. So how are we going to do that? We know that that angle O1 is equal to this angle as well. Those are corresponding angles with this line AS parallel to OM. But now those ones are in the same segment, so we can prove that this angle is equal to that, essentially. So that would be the converse of the 10 chord theorem. So number one, we know for a fact that angle, we can start with S1, angle S2 is equal to angle O1. Right, what is that? These are angles in the same segment subtended by chord BT. Okay, because we know that we were told that stuff is a cyclic quad, so we don't need to overly explain. We can say however, or we can say but, let's keep it simple. But we also know that angle O1 is equal to angle A. What is this? These are corresponding angles with AS parallel to OM. Okay, so we can make a conclusion that therefore it is easy to see that S2 should then be equal to angle A. Again, each is equal to angle O1. So we made O1 our link. Therefore, we can conclude now that TS is a tangent to circle center O at S. Right. Again, what is that? This is the converse of 10 chord theorem. Wow. These guys decided to keep it around the 10 chord theorem. It's been 10 chord theorem all the way. You win. Anyway, anyhow, so that is a strong point technically. That is a strong point technically. And then that is a strong point essentially, as well as the last one. So these ones are just happening. 4 marks in the bag, okay? So let's do 10.2.3. It says prove that TS is a diameter of circle passing through those points. Now, how will we prove that? Obvious. Point T, M, and S. We just have to say this is 90 degrees, right? Because if we prove that that is 90 degrees, the angle in the semicircle is 90 degrees. So this is very easy, but we need to account for S1 and M3. So basically we know that S1 is equal to 90 degrees, right? Now what is this? This is the angle subtended by diameter AB. Easy. Now, what is the next story? We've got a but. What is that? We know that M3 must 2 can be equal to S1. Why is that? Those are alternate angles, with this AS business being parallel to OM. They alternate. They form my letter Z. All right, okay, we can now conclude that technically that business is 90 degrees. As a result, if we prove that, then we know that technically TS is a diameter to circle passing through TM and S. What is that? That is because of the converse of angle in the semicircle. Yes, that is the story. So I don't know why 5 marks. Come on guys, you're joking now. You're starting to make jokes, are you not? This is true, and this is essentially true, and then this one is true. So 3 marks. But where did you get the notion to give 5 marks? Hey, anmen kancinci nina man. Njengathi ndifuna uspayisisa nje. Why ngathi nizama ukuspayisisa bafowethu? For me, that should be 3 marks. Anyway, anyhow, I don't know where the 5 marks are. Maybe it... come on guys, but that story is enough. Would you really be giving marks here like that? Doch, this is crazy. Let's leave it at 4 marks. We don't care why that is the story, but we just move with the story. Kanti kwenzeke ntoni la? Sengino-3 ovele kuphi la? Yey, wena uzongishayisa wena. Anyway, so we want to prove similarity in triangle ABS. Superb. I know I'm tired before I'm tired. STM. ABS is the anti-lock braking system. If you're riding motorcycles and you're driving fast cars, you've got ABS in there. Okay, let's look at these triangles. Where is ABS? ABS is the big one. STM. This is this one right here. Okay, we're looking at TMS or STM and that ABS, which is the yellow triangles. So now let's see, what do we know? We know that angle B in this ABS business is definitely equal to angle T in the other business. What is this? These are angles in the same segment. Subtended by chord OS. Remember, we're told that that thing, BTSO, is a cyclic quadrilateral. That's number 1. We can say also, what is the other story? The other story we just proved above that, that angle A is equal to angle S2. We proved it above when we were proving that 10 chord theorem, right? Right. And we also proved above that angle S1 is equal to M3. That's also proved above. We can say therefore triangle ABS is definitely similar to triangle STM because they are equiangular. That's it. Okay, so this one was the one that maybe we did speak about it, maybe we did not. Yeah, we did speak about it when we were analyzing, but we did not really use anything. So this one is the mark, and then maybe for these two, because they have been given a mark each above, so we can combine them into a single mark, just to try and be comprehensive. Okay, so now let's do 10.2.4. Okay, so we want to prove that AS, where is AS? AS is this side. Okay, is that side of the triangle. MT or TM. TM is this side. All right, yani kona kwenzeki kahle. So can you see we're looking at this side over that side. And then what do we see also? We've got now this business here, it's squared. 2SM squared. Yes. What is the story now? What happened? Now we can see that if a line is drawn from center and is perpendicular to chord BS, it should bisect that chord. So that is where the 2SM squared is coming from, because we've got MS as a portion of the triangle ABS, we've got MS as the side of that, so that's why it becomes squared. So we're going to be smart about our business. Now we're going to start and say essentially AS, if we like, over. Now AS is going to be over. Remember, AS is opposite angle B in the yellow triangle. That angle is equal to angle T. So the side opposite that angle is SM. So we're going to say SM is equal to. Now we can see here we want to use SM, but for now we can use BS. Wow, what a choice there, BS. BS is opposite that angle A in the yellow triangle, but that angle A is equal to angle S2 in the other triangle, and the side opposite it is TM or MT. Okay, so that is the story. So again, this is now the proportional sides in similar triangles. Perhaps we can state where are these in 10.2.3, because sometimes they may be asking what similar triangles and you did not provide proof. Okay, all right, okay, and then here we cross multiply. This implies that now AS times MT is going to be some bullshit right there, times SM. Is it Seringomayelia? Yeah, something like that. Anyway, anyhow, we've got a story to tell. We're like, hey, come on, we're not done, man. But we know that BM is equal to ms. Oh, why is that? We know that line from center perpendicular to chord. All right. BS. All right. Okay, because we saw that that angle was 90 degrees, and so that is the story. So this implies that AS times MT is going to be, now instead of BS, we're going to say this is going to be 2 times MT. No. 2 times SM. Maybe let's write this one properly, the way they wrote it. This is SM. So this is going to be 2 times SM times SM. So BS, remember, is replaced by this guy now. Yeah. But maybe it sounds crazy now. Let's try to be comprehensive. This is the last question, so we need to put it right. So this tells us, therefore, that BS is going to be equal to 2 times SM as a result. Yeah, that's what it is. This then implies, maybe we can say then, let's use the right word, then we know that AS times MT is going to be, instead of BS, we're going to say 2 SM times SM. Therefore, AS times MT is going to be 2 SM squared. Finally. So this is a question that looks a bit horrible. It's one of those silly questions, but they decided to put less marks so that they can hide the fact that it is naughty, okay? So you needed to be very careful around it. Anyway, guys, this is the story, and we move on. For me, this statement is a mark, okay? That was a means to an end, but this statement is important for me. And then this substitution here of that guy, because the answer was already given to us. So we're taking our 21 marks for a big total of 150 degrees. 150 marks. Alright guys, that's the end of our video. I was already losing my head. It's a pity, guys. This was boring, so you should do it yourselves. Otherwise, I hope you liked the video and you've learned something. If you spot any silly mistakes, sometimes I say crazy things. You either ignore those things or you clarify by asking a question so that I can clarify if I am really meaning what I did or I made a mistake. As you know, it's so easy to do those. Otherwise, goodbye.